Hey everyone! In this video, we're going to be taking a look at how to find the derivative of inverse sine. So the first thing I want to do is talk through how we derive this formula, and I want to show you how to use it in an example. So the first thing here, let's just start off with an inverse sine equation. So let's say y is equal to the inverse sine of x. I want to be able to find the derivative of this. So the first thing, if y is equal to the inverse sine of x, we also know that this is the same as the sine of y is equal to x. So switching it so we have a regular sine, now we can go through and we can find the derivative with implicit differentiation because we know what the derivative of sine is. So let's find the derivative here. Let's take the derivative with respect to x of both sides of the equation. On the left-hand side, the derivative of sine is equal to cosine. So we have the cosine of y. But because I'm taking the derivative with respect to x of an expression that has y in it, I also need to include the dy over dx. And then on the right-hand side, the derivative of x, this is just equal to 1. Now to solve for dy over dx, we'll divide both sides by the cosine of y. So we end up with dy over dx is equal to 1 over the cosine of y. So this is actually the derivative of the inverse sine. However, it does have the variable y in there. And what we want is we want a formula that's written in terms of x. So we need to find a way to substitute out that y. And the way we're going to do that is we're actually going to start with our Pythagorean identity for sine and cosine. So remember that the sine squared of y plus cosine squared of y, this is equal to 1. Subtracting sine squared of y from both sides, we get the cosine squared of y is equal to 1 minus the sine squared of y. And now taking the square root of both sides, we end up with just a cosine of y, and this is equal to the square root of 1 minus the sine squared of y. So we have an expression for the cosine of y, but it still has that variable y in there. But earlier in this process, we said that the sine of y was equal to x. So I can actually substitute out the sine squared of y. So we end up with the cosine of y is equal to 1 minus x squared and the square root of all of that. And now we can substitute it out into our formula here. So dy over dx is equal to 1 over the square root of 1 minus x squared. And using this formula, we can find the derivative of inverse sine. So let's use this in an example. So I have y is equal to the inverse sine of 4x squared. So I'm just going to rewrite the formula. So the derivative with respect to x is going to be equal to 1 over the square root of 1 minus x squared. Now taking a look at this equation, we are going to need to use the chain rule on this one as well, because inside the inverse sine, we have a 4x squared. So to find the derivative, using the chain rule, we're going to take the derivative of the outside function, and we're going to multiply it by the derivative of the inside function. Our outside function here is the inverse sine, so we're going to use our formula. So the first part, we have 1 over, and that's going to be the square root of 1 minus, and now instead of just x, it's going to be everything that's inside our parentheses. So we're going to do 4x squared squared. And it's the square root of all of this. So that's the derivative of the outside, the derivative of the inverse sine, and we're going to multiply this by the derivative of the inside. So 4x squared, using the power rule, the derivative is just 8x. And lastly, just to simplify this a little bit, y prime is going to be equal to, I'm going to move the 8x into the numerator, And then in the denominator, we end up with the square root of 1 minus, and squaring this term, 4x squared times itself, we get 16x to the 4th, and the square root. So here's our derivative, a little combination of the new formula we found for the derivative of inverse sine, along with the chain rule.